Hello, this lesson is about a fast and easy way to find out if a number is prime or not. Just a quick reminder about a couple of vocabulary words. Factors are numbers that you can multiply together to get another number. For example, 2 and 3 are factors of 6 because 2 times 3 is 6. 1 and 6 are also factors of 6. A prime number is a natural number or a counting number greater than 1 that has no positive factors other than 1 in itself. A natural number greater than 1 that is not a prime number is called a composite number. Here is a list of 7 numbers. I want to challenge you to within 3 minutes to find out which of these are prime and which of these are composite. It's okay to use a calculator. If you want to skip this, it's okay. But if you want to take this challenge, go ahead and press pause and then we'll come back. So press pause in 3, 2, 1. Welcome back. Let's check out which of these numbers are prime and which ones are composite. The primes are 73, 59, 97, and 83. The other numbers are composite. They have factors other than 1 and themselves. Okay, now it's time for me to show you the fast and easy trick of finding out if a number is prime or not. This trick is so great that you can make a bet with somebody and say, hey, I bet you this $257 that within 1 minute you can give me a number under 200 and I can find out if it's prime or not. Would you take that bet? Well, with this trick, I bet you can. In order for this method to work, we need to review a couple of tricks about divisibility to see if a number is divisible by another number. To see if a number is divisible by 2, I know you know that's pretty easy. All it has to do, it has to end with an even number. To find out if a number is divisible by 3, that's pretty easy also. For example, 81 is divisible by 3 because when you add up these two digits, you get 9. 8 plus 1 is 9. And since 9 is divisible by 3, 81 is divisible by 3.
Suppose we had 681. Well, that adds up to 15. 6 plus 8 plus 1 adds up to 15. 15 is divisible by 3. Therefore, 681 is divisible by 3.
5 is very easy. The number has to end with a 5 or 0. There is no trick for 7. All you have to do is divide a number by 7. If you get a whole number, then it's divisible by 7. Now here is the gist of the fast and easy trick to determine if a number is prime or not. You don't have to think through all the numbers in the whole world, all the numbers less than a number. For example, if you were trying to determine is 83 prime, you don't have to think of all the numbers 83 to see if any of them go into 83. All you have to do is think of the first few prime numbers. If they don't go into it, then nothing will go into it. Therefore, 83 is prime. So let's watch what happens. First of all, we'll try out 39. First, is 39 divisible by 2? No, it doesn't end with an even number. Is 39 divisible by 3? Yes, because 3 plus 9 is 12. 3 goes into 12, so 39 is not prime. Let's go with 59. Is 59 divisible by 2? No, it doesn't end with an even number. Is it divisible by 3? Let's see, 5 plus 9 is 14. 14 is not divisible by 3. No. Is it divisible by 5? No, it doesn't end with a 5 or 0. Is it divisible by 7? No, it's not, because when I divide 59 by 7, I get 8.42 blah, blah, blah. Now, it turns out that's as far as I have to go. I'll tell you why in a second. Therefore, I know for a fact that 59 is prime. I did that in less than a minute, and I could have won that $257. The reason I could stop at 7 is because 7 squared equals 49, which is less than 59. But the next prime number, 11 squared, is 121, which is greater than 59. I don't have to try that. I don't have to try out any other numbers. All I had to do was try 2, 3, 5, and 7. In fact, since 11 squared is 121, any number under 100, you only have to check the 2, 3, 5, and 7. So let's try 73. Does 2 go into 73? No, it's not even. 7 plus 3 is 10. 3 doesn't go into 10. It doesn't end with a 5. 7 doesn't go into 73. I know that 7 times 10 is 70. 7 is not going to go into 73. I can stop right there. Winner, 73 is prime.
Let's try 83. Not divisible by 2, 11, not divisible by 3, not divisible by 5. Let me take out my handy dandy calculator and see what 83 divided by 7 is.
Okay, so I got like 11.857, so 83 is not divisible by 7, and since 11 squared is 121, which is bigger than 83, I can stop right there and declare 83 is prime. Give me my money. Let's try 87.
Does 2 go into 87? No. Does 3? Let's see. 8 plus 7 is 15. 3 goes into 15, so this is divisible by 3. It turns out that
3 times 29 is 87, but all I need to know is that 3 goes into it. That's not 87 or 1, so 87 is not prime. Now let's go ahead and try 91. Doesn't end with a 2.
this adds up to 10, so it's not divisible by 3. It doesn't end with a 5 or 0, so it's not divisible by 5. Let's go ahead and divide 91 by 7. I'll do this by hand.
Oh, 7 times 13 is 91. And thank goodness, because I would have stopped right there. So 91 is prime. Now let's try 97.
It doesn't end with an even number. This adds up to 16, not divisible by 3. It doesn't end with a 5. Let's see if it's divisible by 7.
Well, I get this big old messy decimal, so 97 is not divisible by 7, and that's as far as I have to go. 97. Now here are some of the other prime numbers squared. So any number past 121, you'd have to at least try 11. If it goes past 169, you have to try 13 squared, etc. But most numbers that you have to decide if they're prime or composite or under 100 are pretty close to here. So the trick really still works. That's all I've got for now. Goodbye.